Hello everyone and welcome to this week's OpenGL 3D game tutorial, and this week we're going to be creating some nice looking reflections using cube maps, and we'll also add in some refraction as well. So I have actually covered reflection once before in one of the OpenGL water tutorials, but that was a rather special case of reflection because the reflective surface, the water, was just a completely flat 2D quad. In this scenario, all of the reflections that can be seen by the camera come from the same part of the scene, so we could simulate the reflections by taking an image of that part of the scene and projecting it onto the water's surface. However, if we want to have reflective objects that aren't completely flat, then the reflections don't just come from one part of the scene, they could be coming from absolutely anywhere in the scene. So a 2D image of just one part of the scene is not going to be enough for the reflections in this case. Instead, we're going to need a full 360-degree image of the entire scene, which would look something like this. This is known as an environment map, a 360-degree image of everything in the scene that can be reflected. There are various ways of implementing environment maps, but in this tutorial we're going to be using a cube map texture as the environment map. So cube maps are a type of texture which I covered way back in tutorial 27 when we implemented skyboxes, and if you haven't seen that tutorial, I definitely recommend that you watch that first to get an understanding of cube map textures before doing this tutorial. If you have already done that tutorial, then hopefully you remember that a cube map is basically a cube of 6 individual images, and to sample the cube map you don't use a 2D texture coordinate like you would for a normal 2D texture, but instead you sample it using a 3D direction vector which points in the direction of the part of the cube map texture that you want to sample. This week we're just going to be using some pre-made cube map textures like this one, which you can just load up from your res folder, but in the next tutorial we'll have a look at actually rendering to the cube map so that we can dynamically generate our own environment maps based on our in-game geometry, so that our objects can actually reflect the in-game scene rather than just a pre-made image. But as I said, for this week we're just going to be concentrating on the actual reflection code. So first up, let's have a look at how reflection should work. For any point on this reflective sphere, some part of the scene is going to be reflected into the camera. And you've probably done this in physics at some point, but if this is the surface normal at that point, then this angle here is always the same as this angle here. So for example, for this point, if the camera is over here, then it's going to be reflecting the part of the scene that's over in this direction. And for this point over here, if the camera is here, then it would be reflecting this part of the scene. So in the shaders, for each point on the sphere, our job is to determine the color of what it should be reflecting. We'll obviously know the position of the point and its surface normal, because those will be per vertex attributes, and we can also pass in the position of the camera as a uniform variable, so we'll know where that is. We can then calculate this vector here by subtracting the camera's position from the point's position, and the reflected vector can then be calculated using GLSL's inbuilt reflex function. So we now know that this point should be reflecting whatever's over in this direction in the scene, but we still need to find out what that is, what it should be reflecting. And that is of course where the cube map comes into play. The cube map texture contains color information about everything in the surrounding scene, and the best bit is that we can sample it by using a direction vector. So we just have to sample the cube map using this vector, and that will give us the color of the reflection for this point on the sphere. So to get started this week, I've created a very simple demo that we can try this out on, and you can download the code and the res folder for that in the description. So if you want to code along, you'll need to download that and get it set up in a project which has the lightweight Java game library jar, the LWJGL utils jar, the slick utils jar, and the PNG decoder jar added to the build path. So if you get that working and go ahead and run it, you'll see that it's just an extremely simple OpenGL program where I'm loading up some 3D models and rendering them using code that we used way back in tutorial 11. So at the moment they just have a diffuse texture and some simple diffuse lighting. You'll also notice that I've loaded up a cube map texture, which is what we're going to be using as our environment map, and I've rendered that onto a skybox using code that we covered in the skybox tutorial. So have a look through all the code, make sure you understand what's going on, which I'm sure you will because it's all super simple, and when you're ready we can get started with making these objects nice and reflective. So we're going to start off in the entity's vertex shader, and the vertex shader is going to have the job of calculating the reflected vector, and it's going to pass that to the fragment shader. So we're going to need an out vec3, and down here we're going to calculate that reflected vector. So first off, we need to calculate the vector from the camera to this vertex, and to do that we're going to subtract the camera's position from the world's position of this vertex, and we're also going to want to normalize that vector. And we can now calculate the reflected vector, and we're going to do that by using GLSL's inbuilt reflect function, which takes in the vector that we want to reflect, which is the view vector. It takes in the surface normal, which is unit normal, and it returns the reflected vector. So that's going to get passed to the fragment shader. So in the fragment shader, we're going to need an in vec3 reflected vector. And with that vector, we're going to want to sample the cube map. But in order to sample the cube map, we're going to need a sampler. So we're going to create a uniform sampler cube, and it has to be sampler cube and not sampler 2D. And this is going to be the sampler for the environment map. So we're then going to need to do the usual thing in the static shader class for this new uniform variable. So we're going to have an int to hold the location of that enviromap uniform. We're then going to get the location of that uniform variable, and make sure you spell the name of the uniform variable correctly here. And we're then going to indicate which texture unit it should be sampling from, and to do that, in the connect texture units method, we're going to load up an int to that uniform, and that int is going to indicate which texture unit we're going to be sampling the environment map from. So we're going to be sampling it from texture unit 1, and in order to do that, we're going to need to bind it to texture unit 1 before we render the entity. So in the entity renderer, we're going to create a method to bind the environment map. Firstly, we're going to need to activate the texture unit that we want to bind it to. So we're going to activate texture unit 1 here, so that's GL texture 1, and we're then going to bind the cube map texture to that texture unit. So the type of texture is now a GL texture cube map and not GL texture 2D. And we then just need the texture's ID, which I've got in this cube map object, which I created. It's just a very simple object which contains the ID of the cube map texture. So that's going to bind the cube map texture, and we need to do that before we render our entities. So let's now go back into the fragment shader, and this sampler cube is now all ready and set up to sample the cube texture. So we can now get the reflected color by sampling the environments map. So we're going to call the texture function, we're going to sample the environments map, and we're going to sample it at the reflected vector, and that's going to give us the color of the reflection for this fragment. We're then going to mix the color of the reflection with the material color of the object so that it's not completely reflective, and we can choose how reflective it is by choosing a number between 0 and 1 here. So once you've done that, you can go ahead and run it, and you should now be able to see some nice reflections in your objects. So our objects are now nice and reflective, but we can actually also very easily simulate refraction using the same technique to make our objects appear a bit transparent. When light goes from one material into a different material, it bends slightly or refracts slightly, and the amount that it bends depends on the ratio of the refractive indexes of the two materials. And just like how GLSL has an inbuilt reflect function, it also has an inbuilt refract function which can calculate the refracted vector for us. And this function takes in the vector that we want to refract, the surface normal, and the ratio of the two refractive indexes of the two materials. So using this, we can easily calculate the refracted vector now, and then we can use that vector to sample the cube map to make our objects appear transparent like glass. So let's now implement this in the code. So in the vertex shader, we're going to need to have a second out vec3, which is going to be the refracted vector. And we're going to calculate this using the inbuilt refract function, which is going to take in the vector we want to refract, the surface normal, and then the ratio of the two refractive indexes of the two materials. So I'm going to choose air, which has a refractive index of 1, and water, which has a refractive index of 1.33. Then in the fragment shader, we're going to need to take in that vec3 refracted vector. We're then going to sample the environment map using that refracted vector to get the refracted color. And we're going to be sampling with the refracted vector here, so make sure to change that from reflected vector. And we're then going to mix the reflected and refracted color so that our object is both reflective and transparent. And I'm going to mix these two colors equally, so I'm going to choose a value of 0.5 here. And we're then going to want to mix this with the material color of the object. So let's put enviro color in there. but for now I'm going to boost this up to a value of 1. So as you can see, our objects are now completely clear, and you can see that they're both transparent, slightly transparent, but also they're still reflecting their surroundings. So there's obviously so much that you can do with this, and if you play around with the settings and the refractive indexes, you can get all sorts of different cool material effects. You can also try out some different environment maps if you want in the master renderer, and I'll also put a link to the website where I downloaded these environment maps from in the description, so that you can download some other environment maps and use them if you want. So that is going to be it for this week. Thank you all very much for watching this video. Do subscribe if you haven't already. Have a fantastic week, and I will see you all next time.